Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, we are going to creating here a project which is checking the password strings using machine learning. So without any further ado, let us start our tutorial right now. So this is the code. You can see that in Google Colab and I already added the code here. So you can see that first you need to import it. Here's some of the important library. So what you can do, first you can import them and after that you're going to use it later on in our codes. So first you import here the warnings. So you actually import the warnings so that you can actually ignore here the warnings that is coming from the versions. Let's say you are using here a Python version which maybe have some deprecated library. You use that. So obviously it will give you some kind of warning. So just import here the warnings and just ignore it. And after that, you import the random, the NumPy as NP, Pandas as PD because we need to load our data set from our directory. Then Cborn as SNS so that we can have a look about our data sets in a visual way. Then matplotlib.pyplot as PLT, same thing. And Scikit-learn, sklearn.featureextraction.text, we import here the TF-IDF vectorizers, term frequency inverse vectorizers. Okay. Then after that, the train, test, and split because you know that in the case of machine learning, we need to divide our data sets into two parts: training and the testing part. And after that, we import here our machine learning model, the logistic regressions, as well as we're going to be using here another model which is secret. Higher you go further, then you can see that which model we are going to use it in order to building here this application. But we're using here the logistic regressions for the initial purposes. Okay. Then after that, you import here from scikit-learn.metrics, you import here the accuracy score, the F1 scores, the recall score, precision scores. Okay. And then we give some style because we love the style, right? So we just use the shift enter, or you can also clicking here this button. One more thing, make sure that your runtime should be in GPU, T for GPU. Okay, cool. Now our import data sections. So if I go on here, you can see that we have a file that's called password strings.csv. Don't worry about this CSV file. You'll get this CSV file in the GitHub repository. Just click here and copy path. And then after that, just paste it to here. So data equal to pd.read underscore CSV, and we pass it here our path. And on backline, we just skip. If it have any kind of backlines in the case of passwords, it just skip those. Okay. Again, shift enters. Now you can see that our data set is loading here in our Google Colab. And after that, data.head, so we can see some entity of the data. So in our data set, we basically have the two columns, two features column. One is the password, another one is strings. So you can see the passwords and the strings. Lamborghini one. How cool the password is, okay? And after that, we can checking the shape of that. So you can see the shape. It have the huge number of data. You can see that how many number of password it have in the CSV file. Okay. And then after that, what I can do, we first checking there is there any null value or not, because you know that in the case of data set, it maybe have the human error. So it may have the some kind of non value. So you can see that a password is 1 and strings is basically 0. It's null or sums. It means that it have some non value. Okay. Okay. So okay, anything wrong? Yep. So we can checking this out. So you can see that password have the non value and a string all don't have this kind of thing, because string is nothing but the integer number. You can see the integer numbers. But in the case of password, it have some non value. You can see on here. Now you just drop them. So df equal to data dot drop na. It's mean that just dropping the non value from our data sets. Now if I summing this out, then you can see that 0 and 0. It's mean that it don't have any kind of non value. So what it can do actually, this function is basically returning here the summation of the nulls. Okay, summation of the nulls. So it's basically the non value. It's mean the summation is basically 1. So that's why password is basically 1. It's been boolean value, true or the false. And then we checking this again. We have any in our axis number 1. Just show it. So you can see here non value. Okay. And then you can see we're just going to drop them. Okay, the non value. Now you can checking the values count of the strings, how many value it have. So you can see that we have the 1, 0, and 2. So 0 is nothing but the NaN value itself, and 1 is nothing but the weak, and 2 is a strong passwords. Okay, so you can just have a look about a count plot. So you can see on here, so 0, 1, and 2. Okay, based on the strings actually. And then now what I can do, we just going to divide our data set into dependent and independent features. I mean X and Y. So you can see that we just getting here variables X and Y. Let's say df of passwords and Y of strings. It's mean that we just have the data sets where we basically have the passwords and you have the strings. So a strings is nothing but our the target column that you're going to predict it, right? The password is the weak or the strong, like that. Okay, or the normal, the weak or strong, like that. Okay, so X and Y. So you can see that those are the value it have. You can see passwords uh, and the number of columns. Okay, so you can see that 669639, those are the column for the X of the passwords. And if I see this one, you can see here those are the things. Okay, I think we just have one NaN value. Sorry for that. Actually, it not give me the true and false, I mean boolean value. It just give me how many NaN value it have. So it just have one NaN value. Quite interesting actually. And this is this row. Okay, that's for bad in explanations. Okay, okay, so you can see 1 and 0. So now what I can do, you can see that we have the 0 and 1 and 2. I mean we have the three classes. So we already have the X and Y. Okay, so we can basically go into shift enter and you can check in here the Y. Okay, now we can also check in there, is there any null value or not, and you can see you don't have any kind of null value. Okay, so what we can do, we simply going to creating here a functions which is just taking here our password and try to convert them into some kind of characters. I mean store it inside a character so that we can directly pass it to our TF idea vectorizers. Now why? Because you know that a machine can understanding the number, even though the machine learning algorithms can can actually understand the numbers as well as they can find a pattern from the numbers. I mean numbers to numbers. So that's why you need to taking out the characters and convert them into some kind of vectors representations. So that's why creating here a functions called def characters, and which one is taking here an inputs and store it inside a list. So you can see here we added to all the inputs and store it inside a list. And after that, you're going to pass it inside our TF idea vectorizers, because we have to convert them into the vectors. I mean, same thing for the categorical types, because you can see that this is nothing but the textual data. So we cannot directly pass it to our machine learning models. You need to convert them into the numericals. Okay, but in case of the passwords, because this is the number, so these are the passwords. So we cannot do the get dummies. We cannot go do here the one hot encoding. So you need to do here the TF idea vectorizers. I mean vectorizers form, because these are textual data, right? So now we can just run it down, and then you can just show this out. I mean running to our tokenizers. I mean how many tokens we have. It's mean that it's just basically creating here some kind of tokens for the each number and represent here with some numbers. So if you see the vocabulary, then you can see that each of the characters is represent as a numbers. It's nothing with the tokens. If you have the knowledge of the large language model, you know that what is actually tokens. Okay, even though the basics of the NLP. So vectors dot vocabulary. So you can see that all of the numbers right now converted into the characters as well as with their corresponding numbers. You can see here same like the 100, but it's quite different. Okay. Now you can see these the vectors, and now if you can see the shape of that, and you can shape is mostly similar, but the y-axis shape is increases 1, 5, 3. Okay. Now we can simply go into divide them the data set into training and testing. I mean we just using here the train, test, and split, and then you pass it here X and Y, and test size is 0.2, and random estate is the 1000s. We just give it here 1000s. And now you can see the shape, that how the shape is look like for the training and the testing. So you can see that this is how the shape is look like for the training and the testing. Okay. Now you're going to initialize here our machine learning model. That's called the logistic regressions. I mean the simpler one. So create an instance of that logistic regressions, and you can also do the hyperparameter tuning if you want. And then I feed it to our training data, so X10 and Y10. And after that, I'm going to test it with some the testing data, which one is unseen data, right? It just trained with the seen data, and we just need to test it for the unseen data. That is nothing but the X test. So you can see that X test and Y train that you can see on here. So if I am going to running this out, I'm going to checking the accuracy score, then I can easily checking here the accuracy score you can see on here for the train testing accuracy and the training accuracy that you can see on here. Same thing, you can also print out here the precisions, the FN score, the recall. You can print any of them. Okay. So if I'm going to printing this out, then you can see that just a white. You can printing this out. I'm just going to copy this out, and then I'm going to create here a code shell. And then instead of the accuracy, let's say I'm going to show here the FN score. Same thing on here, FN score. And then I can say that the FN score, because the code is almost same. Okay. Just you need to changing here the functions, I mean the methods. So it will give you the okay. Target is multi-class, but average is binary. Okay, we cannot running here the F1 score here because this is not an binary classifications, because it just pass it here. You just pass it here actually the 153. You can see the shape of that. So you cannot directly checking the F1 score. If I checking the precisions, so precision score and checking the precision score, so we cannot see it here. Okay, you can see the target is multi-class, so you cannot show the F1 score or the precision scores. We can just show the accuracy score, and you can see that accuracy score is nothing but 0.81. So that's why I just import it but not use it here. That's a trick. So higher you use, higher you cannot. So you can see that our testing accuracy is nothing but 0.81%. So it's quite low. So you need to make it more further advanced. So that's why you're going to using here the gradient boostings. Okay. So you can also use the random forest, but I recommend you to using here the gradient boostings. Okay. Then from scikit-learn.ensembles, you import here the gradient boosting classifier, and then we creating an instance of the gradient boosting classifiers, and then using here xtrain and the y-train, and then you just going to feed it out. Okay. So GB model got predict and x test and y test. And if I'm going to running this out and running this out, then you can see here it initialized on here. Okay. So I'm going to closing this out because why? Because it will taking at most 13 to 15 minutes. So I'm not going to run it on here. So I'm just going to clear the output, and you can see the testing accuracy is nothing but 0.91%, because before recording, recording this video, I already training this out and I got in here 91% accuracy. It had almost taking here the 15 minutes. So I'm not going to wasting the time, because I prepared to save the time. Okay. So what I can do actually, I can just save the model. I mean, after training it out, it also taking in your case maybe 15 minutes, because even you see that I change the runtime type in the GPU, but eventually taking the 50 minutes. So what you can do, if you don't want to waste your 50-minute times, so you can just run it for the once a times. I mean, if you wanted to, run it for the multiple times, so just you can run it for the one times. It take the 50 minutes, and after that you can basically saving this out. You can basically saving this out in the Pickle file, so that you can use it later on. So how can you do that? You can import the pickles, and then you can save the vector file, because you need to also save the vector file, as well as you need to save the model files. So you can see that with open the vector pickles, we give it the mode, the right mode, and pickle.dump. And if I see on here, you can see here model.pickle and the vector pickle that we on here. And I already running this out, right? So you can now validate these things. So you can, what I can do, first I need to loading this out. So I can just copy this thing, because I'm not going to or running these shells. So if you run the shell, you will get those kind of file on here. You will also store it, and then you can do validations. So what I can do, I am just going to load the model file on here. So vector and GB model. Now you can see it loaded. Now I can easily testing this out on here. So I can just use here the shift enter. Then now I can do the predictions. Let's say I just give it the password. Let's say Misho. Let's say hash hash hash. Let's say this one. A strong password I'm going to give it to here. Okay, and enters. So you can see 2 point. It's mean that this is a strong passwords. Okay. Now you can also testing this out in an application as well. As well, let's say to give it here and normal passwords. Let's say 1 2 3 normal. So you can see here one. That's when the weak passwords. So two means it is strong passwords. Okay. So you can also creating here applications. So I'm going to using the Gradio. So import Gradio as 0, and you also import here the NumPy SNP and the Pickle file. And we import it. And in the case of Gradio, you need to creating here functions, which one is basically taking here and pass it to our interfaces. So you take creating here functions called, let's say, the def predict a password strings, and you pass it here the input user inputs. And same thing, we convert them into the NumPy array. You can see NumPy array and the back to transformer the user inputs, and then we just do the predictions. And inside here we just give it here create here a Gradle UI. We're using here gr interface, and we pass it here functions inside the parameter of the fns, and inputs the outputs, the title and the descriptions. So if I'm going to run this out, you can getting here one interface, the cool interface. So you can also creating here in Flux applications, or you can also create it here and extensions that you can easily add it to your the Chromes or any here you can add it, so that the user can actually checking the password strings. Okay, so you can checking it here now user input. So let's say give it to here, let's say Chando, let's say I just give it here my name just only, and click here the submit, and you can see that the prediction is basically 0 0. It means that this is the normal one. Okay, because it's considered with the name. Okay, so if I give it to here, let's say Mishu, so click on submit, then you can see the prediction is 1 because it don't have any kind of numbers. So let's say 1 2 3, and now you can see that you can see prediction is basically 1 because it consists in the numbers, right? Now let's say I'm going to give it to here, let's say the special character, let's say this one, this one, this one. Okay, and click on submit, then you can see the prediction is 2. It means that you can also checking that if it consisting any kind of the numbers or the special characters, you can easily checking this out. If I give it here Mishu just hash, just Mishu hash, and click on submit, then you can see that its prediction is 1. It means that it's an normal passwords. Okay, like that. But if you just give it here just only names, like that, it means that it will give you the prediction as 0. It means that this is an weak password. Okay, like that. I mean the weak, the normal, or the medium, or the strong password, like that. Okay, so this is how we can use here machine learning algorithms in order to actually classify the password strings. Okay, super simple project for the beginners. So don't worry, because after so many months later on, maybe 2 or 3 months later on, hope so, we creating here the projects again in the multiple cities. So this is the basics one. So don't worry, we'll coming up with some more advanced projects. That's it from sides. I hope you enjoy it, and subscribe to my channels as well as share with your friends. Thank you and bye bye.